Immune response to typhoid is mediated by TNF. There are many pathways the immune system employs to clear the pathogen from the body. In this presentation, we're going to discuss the pathway that involves the TNF. Typhoid fever is a disease caused by Salmonella typhi. Salmonella typhi is named after the pathologist salmon. Contaminated water, food, all this participated to transmit this disease. There are two main types of bacteria, gram-negative and gram-positive. How the immune cell recognize or distinguish between these two types of bacteria? Well, this depends on the external material, the cell wall of these bacteria expressed. For the gram-negative, they express the lipopolysaccharide, while the gram-positive the immune cell recognizes it by the peptidoglycan, amino acid, and sugar. TNF is a family of cytokines that acts as a hormone. TNF stands for the tumor necrosis factor. It's a family of cytokines. Cytokines is a protein. So there are millions of immune cells interact each other to clear the pathogen from the body. This process is done by the cytokines. Hence, the non-immune cells also employ this mechanism by using the cytokines to interact between each other. The events when the Salmonella typhi invade the small intestine. So here in the picture, this is the jejunum, the second part of the small intestine. Here you see the lining of the small intestine and the ulcerations that occur after the Salmonella invade the small intestine. The main purpose of this presentation to discuss the mechanism of inducing the inflammatory response to the typhoid. So the first event, bacteria induce this viewing from the large picture to understand the main pathway, how it occurs. Bacteria induce the immune response. In turn, the immune cells increase or they release the cytokines, which causes a pro-inflammatory responses that lead to the systematic shock. These are the severe condition or life-threatening conditions for this disease. So the immune cells recognize the pathogen, whether it is positive, gram-positive, or gram-negative, depends on the cell recognition that's happened between the receptors. So in this presentation, we're going to focus on the two main receptors. So TLR stands for the Toll-like receptors. This for the immune cells, the host. The umbrella of the TLR is called BRR, pattern recognition receptors. So it contains many family of TLR. PAM, this for the pathogen, receptor for the pathogen, stands for the pathogen associated molecular pattern. The specificity of immune response here, innate immunity. I'm talking about the innate immunity, not adaptive. So innate immunity has the specific, but it is not as specific as the adaptive immune cell. So how the specificity of the innate in this recognition of the pathogen is occur. So we're gonna draw some about how the process of cell is work. So here the immune cell, the receptor expressed different types of the cells expressed on the immune cell. TLR4 like TLR2, this plasma membrane. Also in the interior or the intracellular compartment like endosome, also there are many different types of receptors. On the other hand, the pathogen, there are the need to focus here. The receptor is being expressed on the cell wall, not in the plasma membrane or the host and the immune cells. So also there are many types of the receptors. The umbrella of this receptor is called PAM. So for the gram-negative, the receptor is PLS. It stands for the polysaccharide. Lipopolysaccharide, PS. Whereas for the positive negative, the receptor is called, this is for the gram-positive. The immune cell recognizes this bacteria gram-positive by the peptidoglycan. So how does that work? So once the binding occurs, so from the pathogen for the specific receptor on the immune cells, TLR4, this pathway, what the Salmonella typhi is binding, because Salmonella typhi is a gram-negative bacteria. Once activated, the downstream pathway lead to produce the specific cytokines called TNF. This is the topic of this presentation. In turn, the TNF act on pro-inflammatory events on the cell to clear the pathogen. So this is like the summary TNF is the outcome of the immune response to the typhoid produced by some myeloid. Myeloid meaning the innate immunity cells, not adaptive. Act on immune and non-immune cells and induce many inflammatory effects. So here is what happened. So there, this is the immune cell. Not all the white blood cells produce TNF. So macrophage, mast cell, dendritic cell, NK cell, and epithelial cell. This cell produce the TNF, also monocyte. So 1, 2, 3, 4, 5, 6. This produce the TNF. This give up the inflammatory pathway. TNF act on immune cells and non-immune cells like macrophage. So this is macrophage. So this is look like the positive feedback. Non-immune cell like liver, hypothalamus, and extra tumors. So what they do after that, after activated and they will use TNF. TNF is act on systematically on the body. It's called inflammatory effect. Its effect on the vascular and endothelium, increase the permeability. So these events cause fluid loss and sepsis, anemic sepsis. So when the disease or the bacteria is distribute all the organs or most of the organs, is called the systematic shock or anemic sepsis. Also causes the result is called acute fever phase. So the systematic shock, most of the organ, kidney or heart is going to be affected. So this is the life-threatening events and the severe conditions. There are two terms I like to explain. It's called dimerization and trimerization. So here the event of the binding, there are two ligands. So the ligand from the pathogen LPS, when binding with the host, is convert. So this binding convert to dimerization. The receptor, there's two receptors come together. Excuse me. Trimerization for the TNF, the ligand. This is the organs or the last events of the binding with the endothelium or with the other cells. So this is the cell. The receptors express three receptors. So the trimerization when binding like this TNF. So when binding the cell to be activated when the trimerizations occur. It is come together like this. This the event causes the vasodilations and fevers and swallowing and etc.